Okay, so again, in the last video we're at this point now where you don't want to keep repeating the same stuff over and over again, um, because we've mostly been doing that since the beginning, and we know what we're doing now at this point, right? So we're just skipping over all the exercises. If you're wondering why I have big gaps between each exercise now, it's because I'm looking at each exercise and I'm looking for the ones that are not introducing anything new, and then I'm only doing the ones that are introducing something new and meaningful. And we've skipped from exercise 2.5 all the way to 4.1, in which case I could have even skipped 4.1 because there was nothing new there. Um, at least not that anything that I've been using already. So now I'm looking at exercise 5 because the rest of 3, exercise category 3 and 4, don't have anything new that I don't already know. And it's looking like exercise 5 category doesn't look like there's anything new either. By the end of the last video that I uploaded, um, we were looking at exercise 5.1 and just trying to understand or remember what composition is. And we know now what it is. It's just, let's see here. It's a is no has a relationship where one class has an instance of the other class, I guess. Um, so let's see, composition. Okay, composition, strong aggregation. So where do we go into more detail about this? These things keep popping up. I don't really like Java Point, but we could take a look at it. So, composition is a subset of aggregation. It portrays the dependency between a parent and its child, right? So, a contact book must have a contact. Um, I think, right? So, which means if one part is deleted, then the other part also gets discarded. It represents a whole relationship. A contact book consists of multiple contacts, and if you delete the contact book, all contacts will be lost. An aggregation is a subset of association, which represents has a relationship. It is more specific than association. It defines a part whole or part of relationship. In this kind of relationship, the child class can exist independently of its parent's class. The company encompasses a number of employees. Even if one employee resigns, the company still exists. However, a contact book cannot exist without a contact because it's a book of contacts, right? And but can't a contact exist? It can exist by itself, no? It's a little confusing here. The composition is a subset of aggregation. It portrays the dependency between the parent and its child, which means if one part is deleted, then the other part is also gets discarded. It represents a whole part relationship. Contact book consists of multiple contacts, and if you delete the contact book, all the contacts will be lost. Okay, well, anyways, so we're looking at exercise 5.1. We know that um, here they're saying composition, right? So a line composes of 2 points. So basically, the line does not exist without the 2 points, right? But can't the 2 points, I mean, anyway, so we can see that because here the class point, um, okay, we have the class points, and you can see here in the line class, there's two instances um, of the point, of a point, right? So it means that two instance variables of type point, which means that the line can only exist if there's 2 points, right? But technically, the point can exist without, uh, can just exist by itself, right? So I just want to look into that a little bit more because I'm kind of confused between composition versus aggregation. I know in the previous videos, quite a few videos, quite a many few videos ago, we actually looked at it, but let's just go ahead and look at it more in detail here. Association is a relationship between two separate classes which establishes through their objects. Is a relationship between two separate classes which establishes through their objects. Association can be one to one, one to many, many to one, many to many. In object-oriented programming, an object communicates to another object to use functionality and services provided by that object. Composition and aggregation are two forms of association. So, okay. Variety belongs to bank ICII. Aggregation. It is a special form of association. It represents has a relationship. It is a unidirectional association, i.e., one-way relationship. It means that a bank has um, many employees, but doesn't an employee have its own bank account? But it doesn't have. They don't have their own bank, right? They have their own bank accounts, but it's not the same thing, right? A bank has multiple employees, right? But employees, let's see, is a unidirectional association, one-way relationship. For example, a department can have students, but vice versa is not possible, and thus unidirectional in nature. So we're saying that students can't have a department. I mean, technically they can, but anyways, in aggregation, both entries can survive individually. Okay, so this is what I want to know. Both entries can survive individually. So the bank and the employee can survive, can don't have to be associated with each other. They can exist by themselves. So if just the employee class is there, that's fine. And if just the bank class is there, it's fine. It means ending one entity will not affect the other entity. Okay, that's good to know. Now, composition is a restricted form of aggregation in which two entities are highly dependent on each other. It represents part of relationship. In composition, both entities are dependent on each other. When there is a composition between two entities, the composed object cannot exist without the other entity. So aggregation implies a relationship where a child can exist independently of the parent. For example, bank and employee, delete bank and employee still exist. Whereas composition implies a relationship where the child cannot exist independent of the parent. Example, human and heart. Heart don't exist with separate to a human. But the human can exist by itself, right? So basically, aggregation is where each class or whatever is associated with each other can exist by themselves versus composition. At least one cannot exist without the other. And this is the instance of composition where a line cannot exist without 2 points, but the 2 points can exist without a line. Okay, so that's good to know. The class diagram for composition is as follows, where a diamond hollow head arrow pointing into its constituents. So One line composes of 2 points. Instead of composition, we can design a line class using inheritance. Um, Instead of a line composes of 2 points, we can say that a line is a point extended by another point, as shown in the following class diagram. A point extends a line sub. Okay, let's redesign the. I like the first one better. Um, Technically, a line does have 2 points, right? Let's redesign the line class called line sub and a subclass of point. Okay, so that's fine. We can move on to the next one and see if there's anything new here and go ahead and explain. So the circle and cylinder classes using composition. So a cylinder composes of one circle. So a cylinder cannot exist without a circle. Um, what does a cylinder shape look like again? I kind of forgot. Doesn't it consist of two circles? Anyways, so try rewriting the circle cylinder class of the previous exercise using composition of the try rewriting the circle cylinder of the previous exercise using composition as shown in the class diagram. Instead of inheritance, that is, a cylinder is composed of a base, circle, and a height. Okay, so they just want us to write cylinder class is composed of one circle. Okay, we already know how to do that. That's fine. We can already skip through this. There was only two um, exercises in the exercise category 5. So now we're going to look at polymorphism, abstract classes, and interfaces. Which we've already kind of looked at before, but this is actually something good that we should do because I always kind of forget about abstract classes, interfaces, and polymorphism, and they're actually really simple. Um, you can go ahead and search it up really quick. Let me just close all these. And you can just search that up. Java polymorphism. In Java, polymorphism refers to the ability of a class to provide different implementations of a method. So, are they saying like overloading? Depending on the type of object that is passed to the method, to put it simply, polymorphism in Java allows us to perform the same action in many different ways. Let's look at Geek for Geeks. The word polymorphism means having many forms. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. Polymorphism is very simple, actually. From what I remember, it's just we haven't been using it that much in the previous exercises. Maybe I think real life is true. A person at the same time can have different characteristics, like a man at the same time is a father, a husband, and an employee. So the same person possesses different behavior in different situations. This is called polymorphism. Polymorphism is considered one of the most important features of object-oriented programming. So remember this. Polymorphism allows us to perform a single action in different ways. In other words, polymorphism allows you to define one interface and have multiple implementations. The word poly means many and morphs means forms, so it means many forms. Types of polymorphism. In Java, polymorphism is mainly divided into two types: compile time polymorphism and runtime polymorphism. Compile time polymorphism, it is also known as static polymorphism. This type of polymorphism is achieved by function overloading or operator overloading. So it is just method overloading, function overloading. That's all it is. Okay, right? But Java doesn't support the operator overloading. I haven't really heard of operator overloading. One second, I'm just trying to adjust my glasses. So we have the test class, which has method overloading or function overloading. It has the same method name for three different methods, right? But they each have their own respective um, parameters which differentiate them between each other. Then we have the base class, which has void fun int, and this is so again, this is overriding, this is overloading. Overriding is when we override a function of another class because they have the same name and they have the same parameters. Versus overloading is the same function name used for multiple functions, in which case they have different um, parameters. So that's literally all polymorphism is. So it's nothing that we don't already know. It's just we need to remember that method overloading and overriding is technically polymorphism, which is just a funny word, a special cool word that you can sound very smart by saying. Um, but in reality, it's actually very simple. So let's just go ahead and look at abstract classes again. Abstract class in Java is one that is declared with the abstract keyword. It may have both abstract and non-abstract methods. Methods with bodies. We have both abstract and non-abstract methods. So non-abstract methods are methods with bodies, and abstract methods are methods without bodies. An abstract is a Java modifier applicable for classes and methods in Java, but not for variables. In this article, we will learn the use of abstract class. Oh yes, I think I remember what an abstract class is. It's just a blueprint, right, for like I guess methods that don't actually do anything. They're just I can't remember. Let's look at this. Java abstract class is a class that cannot be initiated by itself. It needs to be subclassed by another class to use its properties. An abstract class is declared using the abstract keyword in its class definition. So abstract class shape, abstract void draw. So the abstract methods don't actually have a body. In Java, the following some important observations. Java, the following some important observations about abstract classes are as follows. So clearly, there's some grammatical mistakes here. But I'm not the best one to say that because I make a lot of mistakes myself. But anyways, um, so we looked at this before. What an abstract class is. I probably have a video on it. It was probably in Python that I was doing it, but basically, like an abstract class is just a template for other classes that inherit from it to inherit the same methods uh, as the parent class. So it means that they must have the same methods and stuff like that, I think. An instance of an abstract class cannot be created. Constructors are allowed. Right, so you can't make an instance of the class because it's just a template. It's just a blueprint for the other classes that are inheriting from it, right? Like the methods don't actually do anything. They're just there because they're saying that, hey, whatever subclass is inheriting from me, it will have these methods. It must, right? Constructors are allowed. We can have an abstract class without any abstract method, which is fine. Yeah, okay. There can be final method in abstract class, but any abstract class is abstract. In class, abstract class cannot be declared as final. There can be final method in abstract class, but any abstract method in class, abstract class cannot be declared as final. So abstract methods cannot be declared as finals, but there can be final non-abstract class methods. You can define static methods in abstract class. We can use abstract keyword for declaring top level class. If a class contains at least one abstract method, then compulsory should declare a class as abstract. If the child class is unable to provide implementation to all abstract methods of the parent class, then we should declare that child class as abstract so that the next level child class should provide implementation to the remaining abstract method. Right. So, like I said, it's just a blueprint. The abstract class doesn't do anything. All it's there for is so that the class that inherit from it all have the same methods, or they should. Interfaces in Java, interface programming languages. So all these things, no wonder like people forget what they actually mean, even though they know what it is, like know what it how to do it. It's just so simple that remembering these names is just. Anyways, an interface in Java programming language is defined as an abstract type to use to specify the behavior of a class. An interface in Java is a blueprint of a behavior. A Java interface contains static constants and abstract methods. The interface in Java is a mechanism to achieve abstraction. There can be only abstract methods in the Java interface, not the method body. It is used to achieve abstraction and multiple inheritance in Java. In other words, you can say that interfaces can have abstract methods and variables. It cannot have a method body. Java interfaces also represents the is-a relationship. Okay, so this is basically kind of what I was saying about the abstract class, except that in the abstract class, if I remember correctly, we can have non-abstract methods, right? Let's go ahead and look that up again. We have the polymorphism here, which is just overriding and overloading, and then we have Java abstract class. Abstract class is a class that is declared abstract. Declared with the abstract keyword. It may have both abstract and non-abstract methods. Right, so we can have non-abstract methods. Um, Abstract is a Java modifier applicable for classes and methods, but not for variables. And then versus here, interface is defined as an abstract type used to specify the behavior of a class. Interface is Java blueprint. Contains static constant. Java interface contains static constants and abstract methods. So the variables are static; they don't change. The interface in Java is a mechanism to achieve abstraction. Can be only can only be there can be only abstract methods in the Java interface, not the method body. It is used to achieve abstraction and multiple inheritance in Java. In other words, you can say that inheritance can have abstract methods and variables. It cannot have a method body. Java interface represents so not for variables. Versus here, abstraction, abstract methods and variables. So basically, interface is a more abstract type of class, and the abstract class is kind of weird, but whatever. Gonna have a method body, and we decided type of entity. Okay, so I think that's kind of all that we really need to know. Um, and then for this exercise, bold means, or at least here, I'm guessing in general, it just means overloading. Um, bold and italic means something different though. Java, bold, italic, UML class diagram. Uh, bold. So abstract methods are bold, italic. Abstract methods, right? So these methods are abstract because they're bold, italic, and then these methods are bold because they are overloading, or actually they're overriding. They're overriding the parent's abstract method. Okay, so I guess that's what we're gonna do. Um, it's definitely something that we don't do much, and we haven't really done much in the other exercises. So it's good to familiarize ourselves and remember by writing down these programs um, a lot. So yeah, that's what we're gonna do. We're actually gonna start exercise 6.1 of the exercises category 6, exercises on polymorphism, abstract classes and interfaces, which is nothing difficult. Again, we already know about overloading and overriding. It's very simple, which is polymorphism, and you already know about abstract classes and interfaces, which is just the actual blueprint kind of classes. Um, yeah, so I'll pause this video and then I'll write down everything and then I'll explain everything when I'm done. Okay, so I finished the program. I mean, honestly, there's nothing different, really, besides the fact that we're now using abstract classes. Um, I think the thing was that I thought we were using abstract classes before, which we're more than likely not, because just before I started the exercises on this website, I was learning Python, and I was using abstract classes and interfaces. I don't know if our Python's version of it, um, if there's such a thing, because I can't even remember if there's such a thing. Like I know Python is an object-oriented programming language, just like Java and C++, but yeah. So that's the new thing that we're learning in this exercise is polymorphism and abstract classes. Um, polymorphism is something that we've used before, and I've already spoken about it. It's just method overloading and overriding. Um, if we read the UML class diagram here, it says that the shape class is an abstract class. You can see here, and then now we're also using another new thing is we're starting to use protected access modifiers, which is just a naming convention is different, but it changes the access um, of the variables and even the methods, but we're not using it on methods yet. So we have two protected method variables, instance variables, color and filled. they're initialized with a string value and a Boolean value, respectively. And then down here we can see extends, so we're inheriting here circle and rectangle are both being extending shape class. So that means that they inherit every everything about the shape class. Um, and then since shape class is abstract, um, as you can see here, so the shape class is abstract. If a class is abstract, you must declare it as abstract here. Um, it has the abstract methods, get area and get perimeter, which are abstract because we know they're abstract because they're in bold and italic. Italic is when the words are kind of leaning towards the side. You can see it's not straight like the other. Like right here, you can see this one's just bold. The two-string method for the shape class is just bold. It's not italic because it's not leaning towards the side like that. These two abstract methods. The abstract is it's bold and it's italic, so it's leaning towards the side. I'm still not sure what the bold is for the methods. I'm just assuming that it's method overriding. Method overriding, because that's basically what the two-string method is. It's just method overriding. It's overriding the string class's two-string method. Um, and that's that for the shape class. We can see here we have abstract class shape, two protected access modifiers for the instance variables here, and we have the non-parameterized constructor, the parameterized constructor here. We have the getter methods, the setter methods, and then we have two abstract methods, and you can see how the abstract methods are written. They don't have a method body, so they're missing this, the curly braces, and to basically say that it's finished, we use the semicolon at the end. You can have parameters for the abstract methods, I think, but they're not asking for that. And then we have the two-string method, as usual. And here we're going through the circle class, which you can see extends the shape class. So that means that because the shape class is an abstract class, the let me see here, the immediate child classes or subclasses that inherit from the shape class, they must implement the abstract methods of the abstract class. So there's only two abstract methods, get area and get perimeter. And this is, I think, one of the reasons why they use abstract classes is because they want to enforce, right, the usage of a certain method or like so. I don't think there's abstract variables or instance variables or variables in general for abstract classes. That would be the interface, I think. Interfaces is where you have abstract methods and variables, or instance variables at least. Um, but here we see we have a protected variable, and then we have three constructors. One is non-parameterized, or somewhat people like to call it a no argument constructor. Not me. And then we have which is probably the right way to say it, but I don't know. I don't know. I call it non-parameterized. Um, we have the parameterized constructor here with one parameter, and then we have another parameterized constructor with three parameters, and we have the getter and setter methods. And then here we have method overriding. So get area here and get perimeter here. We must implement them because They're abstract methods from the abstract class that we inherit from, so we must implement them. If we don't implement them, we're going to get an error. So if I could show you guys here, if I just comment these out, just comment one of the methods. What the heck was that? If I just comment out the get area method, you'll see here that there's an error. It says the type circle must implement the inherited abstract method shape.get area. Right, so that's the one that I commented out, the get area method. Any abstract method, right, must be in which case a subclass inherits from an abstract class. It must be implemented into the subclass, or there's going to be an error. And then we have the toString method as usual, and it's pretty much the same thing for the rectangle class. Nothing different there. Still have the protected instance variables, and then we have extends shape, and then we have non-parameterized constructor, and then two parameterized constructors, and getter and setter methods, and we have the get area and get perimeter methods that we must implement, and then the toString method, and these methods are overriding, and that's what we're talking about here. The bold, I think it means overriding. So we're overriding the parents class, and that's kind of what method overriding is when you override another class's methods, which means that you're using the same name for a method of a different class. And then method overloading is when you have multiple of the same method names within the same class, but they have different parameters. And then we have the square class, where I think there's an issue here. They forgot to put the instance variable side, which I just went ahead and put here. I made protected. I just assumed, right? Because if you don't have this, then there's going to be an issue with your constructors. We're going to give an error saying that there's no such instance variable or whatever in the class. And then here, the color is set. The filled value is set. We can also look here, I forgot to mention, for the constructors, we have the super keyword or super method or whatever, which just calls the constructor of the parents class and initializes an instance of that class with the values that are passed here. I tried to use it here, like so, but it seems like you can't do that unless it's from the immediate parents that you're class that you're inheriting from. So the immediate superclass you're inheriting from, which would be rectangle, right? Square extends rectangle, in which case rectangle extends shape. But when we're using the super keyword here, it's actually looking for a constructor in the rectangle class, not the shape class. And there's nothing matching this case where the constructor in the rectangle class has a string and then a boolean only as parameters. So that's something that I didn't know. There might be a way to do it. I just don't really know right now. But yeah, it's literally that simple. And then we have the set width and set length, which are also overriding the parent class rectangle. This from the square class. The rectangle class also has a set width and a set length method, so we're overriding it. And that's it. That's all it is for exercise 6.1. Next exercise, we're probably going to do exercise 6.2, even though it doesn't look like there's much that's different at all. Actually, it looks okay. It is. It's an interface, so we're using an interface instead. So we're gonna do that in the next exercise. So thanks for watching. See you guys in the next video.